In this lecture, I'll be talking about secrets. Secrets provides a way in Kubernetes to distribute credentials, keys, passwords, or secret data to the pods. Even Kubernetes itself uses this secrets mechanism to provide the credentials to access the internal API. That means that pods have access to secrets, and those secrets must be distributed using this secrets mechanism. In the demo, I will show you exactly how it looks like. You can also use the same mechanism to provide secrets to your application. If you have an application that needs credentials, you can use this same mechanism. Secrets could be, for instance, a database login and password, or anything that needs to be kept secret. Secrets is one way to provide secrets, native to Kubernetes. There are still other ways your container can get its secrets if you don't want to use the secrets in Kubernetes. For instance, you could be using an external vault service in your app. There are external vault services that you can use that your app might be contacting. So you can write that completely in the app layer. You don't really need Kubernetes for that. I'll be explaining this native Kubernetes secrets in the next coming slides. Secrets can be used in the following ways. You can use secrets as environment variables. So in your application, you will just have to read the environment variables, and that's where the app will then find the secrets. You can also use secrets as a file in a pod. This setup uses volumes to be mounted in a container. In this volume, you have files. So in your container, you're going to have a volume. It means it's just a directory that your app can access that contains then those secrets. It can be used, for instance, for .env files, if you are familiar with those, or your app can just read this file or these files. So your app, you can just write some code that says you need to go and look in the specific directory for the secrets that you need, for instance, to connect to a database. You can also use an external image to pull the secrets. Obviously, from a private image registry, you cannot put your secrets in a public image registry. In that case, it would mean that you will have a second Docker image, and that image would be pulled, and your app would then read the data that contains the secrets from that image. First, you need to generate the secrets. So you have a login and password, and you need to put that in Kubernetes. To generate secrets using files, you can use these commands. So first, we're going to create those files. If you don't have them already, you're just going to create a file username.txt. We're going to put root in that file, and we're going to create a file password.txt, and we are going to put the string password in that file. Then you can say kubectl or kubecontrol, create secret generic. It's a generic secret. You give it a name, and you say from file username.txt and from file password.txt, and then you have the secret database user pass that has been created that you then later on can use. A secret can also be an SSH key or an SSL certificate. Here you say kubectl create secret generic, you give it a name again, SSL certificate, and the from file is a key rather than a username or a password. So that's a way to distribute keys, for instance. If you want to generate secrets using the YAML definitions, previously we always used the YAML files, you're going to create a file secrets.db secret.yaml, and this definition is going to be of kind secret. You're going to give it a name, a type, and then you're going to supply the data. Here you're going to supply base64 strings. On the right, you see how you can generate those base64 strings. So you need a Linux or Mac machine, or you can search online for a base64 generation tool. You say, I have the string root, or you have the string password, and you generate a base64 string for that. Then you use that in your YAML file. After creating the YAML file, you can just use kubectl to create the database secret. Once the secrets are created, then you can use them. At that point, you have the three options. I will show you the two most common ones, which is the files and environment variables. If you're going to use environment variables, you can create a pod that exposes the secrets as an environment variables. Here we have the pod definition that we always have been using. And what you're going to do is you're going to add env You're going to give your environment variable a name, and then you're going to say that you want to have the value from another source. The source is going to be the secrets, and you're going to say that the name in the secret is database secret, and the key that you want is username. Database secret is the name of the object in Kubernetes. The key is username. The value will be then the secret value that you stored in Kubernetes. You can do the same with other environment variables that you want to have in your pod. Alternatively, you can provide the secrets in a file. Here we have a volume mount within our container that you want a volume. Volume mount, we give the name, we give the path. So this is the path that your app will have to use. It's etc creds. Read-only true, your app that is running in this container cannot change this, can only read this. And then we're going to have a volume definition. And in this volume definition, you're also going to define a name, cred volume. So this name, cred volume, must be equal to the volume mount, because in the volume mount, you're referring to a volume here that you're creating. This volume exists of secrets. So we're going to say secret with a secret name, database secrets. So all the keys and values of database secrets will now be inserted, will now be put in this etc creds folder, and the secrets will be stored in etc creds, database secrets, the name of the secret, and then the keys. You have the key username and password, so you will have two files, username and password, that the application can then read. The only thing that the application needs to do is read those files, and it can then use the secrets within the application. Using volumes and using environment variables, using these two ways, I will show you in the next demo.